So now in this video, we have an NPN bipolar junction transistor. It's basically a switch. It is off when it is bright enough, and it is on when it gets dark enough. The lamp is at the dimmest setting right now, so that's not dark enough, although I can put my finger over it. And it does look like it turns on pretty good, but there you can see kind of a middle ground region right there. So you'd have to address that if that's a problem. Because switches generally are either on or off. Yeah, that's a very small range. We basically are completely off or completely on unless the light level is, in a specific range. So, in any case, we'll zoom in. First off, this is a 5-volt power circuit right there. I remembered to put the power supply to 5 volts. It was 12 volts in the last video. So that's just something just to remember. Normally I have 5 volts. I could have forgot it and then see that the red LED was way brighter than it should have been, and could have done that. So always double check when you wire up a circuit that the power supply is to the voltage that it needs to be. So yeah, this is a switch, NPN bipolar junction transistor switch. You get a little bit of current from base to emitter, and you'll get a lot more current from collector to emitter. It will allow it to pass through. Ultimately, in this circuit, we got 5 volts. When the transistor is conducting, it's the load here that limits current. Red LED drops about a couple volts, and then we got not 5 volts. We got the 5 volts. LED is probably going to drop 2 volts because it's red, and the rest of the voltage, 3 volts, goes across the resistor right there. And, for the light level, that's what this 22K resistor is. It helps set the sensitivity. So if we used a lower or higher value, then it would be either harder or easier for the light dependent resistor to overpower it and ultimately turn the transistor off. So we got current flowing through the 22K resistor. It's either going through the base to emitter there, or it's going through this resistor, depending on how much this resistor wants to let pass through. So we got more light. This is conducting better right there, and thus it is holding the transistor off. That's why the LED is off. If we get it dark enough, then it's like it doesn't exist, and then we got current flowing through the base to emitter, allowing the collector to emitter to conduct. So I liked this for the light level, but we should still be able to turn the transistor on because this is 100 times as much resistance as the current limiting resistor there, and so for whatever amount of current we get base through emitter, the transistor, if it's only letting 100 times the current go through, it will do so. We're limiting the current more than what it would take for 100 times, and the gain is actually probably about 200 to 300 for this particular transistor as well. So we got plenty of room. Maybe even a 50K resistor might work. I don't know for sure, but just thought I would mention that. So yeah, light dependent resistor gets up to about 200 mega ohms. That's millions of ohms if it gets dark enough. Apparently I tested that at some point or whatever, and if you get it bright enough, you can get below 50. So I believe like really bright light I was able to get down to 30, but I'm pretty sure 60 is not too terribly hard. Oh, also I wrote the states on there. So some of my diagrams I wrote more notes than other. The vast majority of diagrams I show I made a long time ago. So saturated, that is when the transistor is on completely. So it's probably saturated right there. And the active region is when it gets dimmer. There we go. That would be the active region right there. And cut off would be completely off, turned off. That's the 3 states of the bipolar junction transistor. So it's saturated when you got enough base to emitter current to get the transistor to conduct, better than what the load. The load will be what limits the current, not the transistor. If current's flowing, but the transistor is limiting it, the load would take more if the transistor was conducting better. That's the active region. And then cut off means the transistor's not conducting. It's like an off switch right there. And so yeah, that is about it. There's the symbol. If you're unfamiliar with it, collector, up there, base there, emitter there. Usually it's not showing on there. Hopefully there's a part number that also helps you narrow down what transistor it is. You don't have to use the 2N3904. You could use the C945. And I don't know why I picked this one. I probably got it in a kit or something. But it has a different pin layout. Be aware of that. So the emitter to the left is the bottom one, and base is the middle, and collector on top. That is how I have it on the board right there. And we're not going to take a voltage measurement in this video. I probably earlier video had like an oscilloscope I put there or something so we could watch the voltage change, but I don't think that's very helpful. You get 0.6 volts or more. You can't really go up more because it's like a release valve, but you get like 0.6, 0.7 volts. Current will flow and it will be on. You stay below about 0.6 volts and it's not going to allow current to flow, and that's when it will be off. And right when you start hovering around 0.6 volts, just a little bit, that's when it's, you know, partially on. But it's ultimately dependent on the amount of current flowing base through emitter. You'll get probably at least 200 times as much current that could flow through collector to emitter. But it could also be as low as 100 times as much. That's called the gain. So if it has a gain of 100, for every amount of current you get through base to emitter, it will allow, if it's 100 gain, 100 times as much. And then gain of 200 will allow 200 times, gain of 300 times. But it's also variable. It's not set in stone with these transistors, but some part numbers have more gain than others under the same circumstances. So be aware of that as well. But in case I rambled on long enough, hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.